My name is Oleg Kostyukovsky. I'm part of Oracle Java Embedded Group. You probably have seen part of the demo grounds on the Java demo floor dedicated to embedded technology, so I'm part of that group. I'm a solution consultant, and my focus for last year or so was machine-to-machine application of Java technology. So what I'm going to be talking about today is one of those applications specific to the energy smart grid, but also in general we'll talk about M2M applications of Java technology. And well, first of all, thank you for coming here. I know that it's the end of the day, and I've been to enough of those conferences to know that you're dead tired by now. So I do appreciate you coming here. And this session, this is not a session, by the way. This is BUFF, right? So I don't know if you guys been at Java ones in the previous years, and I mean like number of Java ones. You probably know that BUFF was designed not to be a session, right? BUFF was created for people to have a conversation, people to discuss specific topics. I have seen a number of BUFFs recently, and they have nothing. They're nothing like that. They're just another session. So I have a slide deck. I go through the slide deck. You listen, and you go home. So I do have a slide deck. Right? And if you're not going to engage in conversation, I'm going to run through the entire slide deck and bore you to death. But I guess points that I'm trying to make is that I welcome your participation. I don't mind if I won't be able to cover all the slides that I have in the deck. That's fine with me. If we can go home from here understanding each other's views and understanding where we are in M2M space, where Java is in M2M space, where do you see Java going in M2M space? Is there a space for Java in M2M? Your experiences, I'll be the happiest person in this room. So, Java-based home gateway for intelligent smart grid of the future. Original title was much shorter, but I was told that we need to make it a lot more fancy, so somebody come up with that title. Okay, so if I will make you go through entire slide deck here, we'll talk about some basic concepts of energy grid, grid in transition from traditional grid to smart grid. We'll talk a bit about evolution of a smart home, where it is today and where it is going in the future. We'll switch then on to talk about a proof of concept of smart energy gateway. I don't have the demo here. I was thinking about bringing demo here, but it's not, in my experience, showing demo at the session is not working out that well. We have the demo at the ground, at the Java demo grounds. You're welcome to, if you haven't seen it yet, you're welcome to come by and take a look, and we'll run you through all the gory details of the demo step by step, and you can see it there. So I'm going to I have some screenshots and explanation of all the components, but I welcome you to see actual demo at the demo grounds. So we'll cover a couple of different technology aspects of the demo, more specifically demand response principles and technologies. Briefly, we'll talk about Zigbee and how we implemented a Zigbee component as a part of the demo. We'll look at the architecture, high-level architecture of the demo and event flow. And I also have a few screenshots or snippets of the codes that we used to implement this demo. I also personally found it of limited benefit to see code snippets at the sessions, but I have it nevertheless. And last part of the discussion, and this is where I really hope you will guys participate, is where are we going with all of this? Why are we talking about smart grid at Java 1? How it relates to machine-to-machine, emergence of machine-to-machine applications. Okay. Any questions? Oh, by the way, feel free to interrupt anytime. Okay. Well, energy grid is basically, if you go and you ask a utility guy in the past, even now probably, ask you, so give me about 20 seconds explanation of what the utility grid is. And they'll tell you, it's an electrical station where electricity is generated. There is a transmission, high voltage transmission lines that take it to the substation. Then there's a distribution system where you take it from substation to the homes, and that's where it ends. The utility will tell you that our business ends at the meter. With the emergence of the smart grids, it really changes because it involves participation of the consumer in all this ecosystem of a smart grid. There's a notion of smart appliances, there's a notion of on-site energy generation, there's a notion of on-site energy storage, and a number of other different concepts that influence technology event flow involved in the smart energy. So I'm sure there's people from different countries here, but in the US, the electricity grid was created as it is today, pretty much, about 90 years ago, in like 1920s, and it really hasn't changed that much in more than 90 years. Electricity flows in one direction. It's all centralized, meaning that electricity is generated on one side and flows to the consumer. And everything, data collection is pretty much done manually. In California for years, it's changing now, but for years we had a person who come to your home, take a manual reading of the meter every quarter or every 6 months. That's basically what it was. It's completely non-automated. So transition to the smart grid, and this is where our interest as a technology guys are coming, is a major improvement of injection of technology in energy distribution grid. And I mean injection of technology in all the components of the smart grid, from generation to distribution to transmission, and more importantly at this point, inclusion of the consumer technologies. And this is what we're going to be spending hopefully most of the time talking about. How does applications and devices on the consumer side, whether it's homes or businesses, are affecting evolution of the smart grid. On next slide, it's a very busy slide, but what I'm trying to say here is that there's 3 stages. At least we see 3 stages in evolution of a smart grid, and the first stage is deployment of the hardware devices on a grid. So in California, if anybody is for local, PG&E or Northern California, PG&E have deployed PG&E is our local utility provider, already deployed close to 9 million smart meters. Now, reality is none of them really function. I mean, other than do whatever the standard meter does, they do nothing else. Well, they have a Zigbee chip in it. It's not activated. In some areas, the only thing they enable is the remote meter reading when they read meter data over the network. So the first stage is basically enabling, putting devices in place to then enable other technology or other application over those devices. The second stage is start using it, start collecting data, start analyzing this data, and start using this data to improve reliability of the grid, start implementing a cost savings that smart grid promised to deliver. So that's the next stage. That's not happening yet. And it's really, to a large extent, to the high technology, to high-tech guys, to the high-tech industry to come up with a solution application to make it happen. So zoom in a little bit on the smart home services, because historically our group, Java Embedded Group, was very focused on consumer devices. You might probably heard many times about Java in Blu-ray players and Java in smart pens and Java in various others in smartphones. So we were focused on the consumer technologies. And it's naturally sort of leads us to look at what smart grid evolution brings into the consumer homes. So what we see right now is going on is transition from a standalone connected devices, and you can think of your cable TV box receiver, right? It connects to the cable service provider directly. If you use any of the medical devices, they most likely directly connected to your service provider. If you have security at your home, if you have a security camera, it's connected to a service provider, security service provider. So devices that are directly connected to a service provider for this particular application. Gradually we see transition from that to what we called a connected silos. It is where we first time see introduction of the gateway device. Gateway device is something that has a upstream connectivity and downstream connectivity. Upstream connectivity to the service provider, and downstream connectivity creating local home area networks that enable them to talk to different devices on a local network. So you can think of, in the smart energy space, you can think of a smart energy gateway connecting upstream over PLC, for instance. It's a network over power line technology, or connecting over wireless technology, GSM, or using available broadband in consumer homes, connecting upstream to the either utility or service provider, and downstream talking to various sensors and devices within home to gather sensor data and control devices and appliances within home area network. Just a second, I need to get my drink. Oops. Now, as you can imagine that, or at least it's easy to imagine over time, it will just completely roll out of control, right? You might end up having 3, 4, 5, 6 different conflicting networks in your home. If you have a service, if you have your home Wi-Fi, and you have your smart energy gateway, and you have your healthcare device, they all will creating local network. It's just not efficient, it's not effective, and it creates a barrier, silos, where different services are unable to communicate with each other. So what we see is going to happen in what we hope is the near future, and we have some indications that it's already happening with some of the larger carriers, is emergence of what some call a master gateway device. So it's a multi-application, higher-end device with a higher-end operating system, with a clearly defined horizontal services, whether it's a security, application management, application lifecycle management, something that would be delivered by the platform, and all the vertical applications, same applications that we talk about, healthcare, media, utility, security, will be running on the same platform. It would enable not only a lot more efficiency in the home, but it will also enable that platform to be used by multiple different service providers. You can imagine that if you have such a platform running in your home, the service provider could simply push another application onto the device and enable new service within consumer homes. You can think of you going to the Sears and buying new, give me appliance, a refrigerator or dishwasher, smart dishwasher, install it in your home, and then Whirlpool or GE, whoever you bought it from, simply pushes another application on this master gateway, and now you have a control over your dishwasher. Yes?
Who would own the gateway?
Today, it's a service providers. I think that carriers are interested in doing it. Problem with carriers is that they are looking for the new streams of revenue, especially in Europe and North America, where they're sort of exhausting the customer base, and new customers are coming by, trying to attract them from competitors. They are looking for new ways of monetizing. If you're living in North America, you probably know that it over last few years or last decade, it went through double service, triple service, quadruple service, meaning they bundling, trying to add value. They give you TV and cable, and then TV, cable, and phone, and then TV, cable, phone, and home security or something else. So they're trying to bundle services to give you more value. They're running out of that option too, because everybody offers triple play and quadruple play nowadays. So what they're looking for is new services. And this is, just 1 second, let me just finish, I see. And this offers them a way to use the same networks. They essentially don't have to build up new infrastructure to deliver new type of services, make more money on it. So we see Verizon's and AT&T and Deutsche Telekom and NTT are really carefully looking into that. Yes? Mm-hmm.
The cable company is going to say, here's my gateway. And so what you end up with is all of these little gateways that each think they want to be, because the provider wants to bill you for the gateway service.
Yeah, absolutely. There's going to be war. Yes.
That was sort of my question.
Yeah. Well, yeah. There's a business aspect and there's a technology aspect, right? On the technology aspect, it makes sense, and everybody will start pushing it in the recent years. Yes.
Does it make sense to have possibly like a stage 2.5, which is which you own your own home gateway, and that manages all the little gateways that each provider puts in the home? It's like a.
This is like buying your own cable box?
No, you still get the cable box from the company, but you have like a little server that talks to that cable box and tells it what to do. That way you remain in control of your gateway. But because all of these companies are going to do their own proprietary thing, right?
Yeah.
Unless magic happens and we get them all to operate on the same platform, you're going to have those little silos, with each company providing their own. I'm not sure if we can get. I don't know if we can get to stage 3.
So I can tell you that is an interesting thing that happens in that space. I know that I talked to you before, and a lot of carriers who are pioneering this, who are first to deploy that type of gateways, that they see as a multi-application gateways, are actually using the same technology, right? They're using Java and OSGI. They are, OSGI, for those who are not familiar, the Open Services Gateway Initiative. It's something that's been around from late 90s, 98, I think, or 97 when it first was announced. And at the time, it was targeted. It's a specification, by the way, that was created by a number of major carriers, including guys like AT&T and Italia Telecom. There was a dozen or so of major carriers who pioneered this technology, specification.
But would they have kind of protocol like SMMP or something to standardize the way that we communicate to the home gateways?
Absolutely. Again, if you start looking at the area of the specification and standards, that's a hairball too. But think about this, right? I have a slide somewhere. I need to. Where's my? let me fast forward, because I want to show you something that I found interesting. And we can go back to the rest of that here, right? If any of you did a enterprise development, application server development, right? Look at those five, and being around long enough to see how application server evolved over the years and why it was created in the first place. That should look familiar to you, those 5 points. Remember enterprise space when everything was proprietary? Yeah? When there was a mainframe and each mainframe had its own operating system? Right? And there was no interoperability whatsoever. They're probably still running somewhere in the back rooms of Bank of America. Right? Everything become IP-based, right? In enterprise, everything is IP-based. Horizontal platforms. How many application server technology exists today? I mean, not talking about implementation. There's .NET and there's G2E. Pretty much it, right? Each platform provided standard security, standard application deployment, standard application development technologies. So what we see here is a transition in the enterprise space from highly fragmented, highly proprietary technology to very standard open technologies. It happened, right? I mean, it wasn't easy, right? Because there was major players in the market were competing to become providers of that standard and providers of that technology. But it did come to that. It might take time, but I think the same thing would happen on a device, in the M2M space as well. And similarly, it will have to provide us an array of services that would give a common platform to those applications. I already mentioned security. Right? If you talk to either carrier, large carrier, or a small company who are providing a point application, they don't really want to worry about how do they implement technology. They don't want to implement their own way of develop or deploying application and monitoring application on device. They want to focus on what they are really good at creating an application that address specific vertical requirements. Right? If it's a smart energy, it's a smart energy application. If it is a healthcare, it's healthcare. They don't want to do security. They don't want to do application management. Right? So, you tell me, right? And I'm preaching this because I want this to be Java. Right? You're the one who's going to be consuming it. Does it make sense? And I see the hand over there.
So following up on his point, are people starting to standardize on? I mean, there have been things around like sensor ML and CoAP and EXI for a little while now. Are people starting to standardize on any of those technologies at this point, specifically for the data format, from these sensors to the data?
Yeah. Well, the web services are becoming one of the standard. As far as the communication protocols, we see transition to IP-based communication, right? Good example is Zigbee, right? If you're at all familiar with Zigbee, Zigbee is something that was created, it's proprietary specification, right? It's controlled, it's not open, so there's a problem there. But it was created by the Zigbee Alliance and was based on RF technology, or radio frequency communication. Now they start gradually moving to IP. So and again, I will move backwards to illustrate what I'm talking about, because I do have a slide for that. Yeah, so this Zigbee spec are mandating specific transport protocol, right? And it's not IP-based. What happens is in the so-called Smart Energy Profile 2.0, they drop this requirement. They basically say that our Zigbee stack. And this is basically the networking structure, the security, the implementation of different profiles would run on any IP compliant communication protocol, whether it's a Bluetooth, oh no Bluetooth, whether it's a Wi-Fi, PLC, whatever. Right? So this to me is indication that at least in this area, there's a movement toward more standard platforms or basis for implementation of communication protocols. As far as others, again, maybe it's a wishful thinking, but if we can get to the point when we will start coming up with a more standard platform, the community will rally and start developing plugins, right? Because you're talking about a M2M, as you I'm sure all know, is concept, right? M2M, but on its own, is nothing. M2M is only takes a tangible physical form when you start talking about specific industries, transportation, logistics, smart energy, and on and on and on. And each of those areas, there's very specific requirements for communication, for device interoperability standards, for security, right? Security in healthcare, in data retention policies, and all this is completely different than maybe in transportation. But my hope is that over time, the horizontal platform would allow people who know how things work in healthcare to start developing plugins that would work on the top of general platform. Just like in enterprise, people developing JDBC drivers, right? Application server doesn't need to know how the specific database works, right? If database provides its own JDBC driver, application server knows how to pull data from that data source. That's what I'm hoping is going to eventually, it's going to take time, but would eventually happen in the M2M space on devices. Okay, yes?
Like the OGC, I don't know if you're familiar with that, like, the SUI concept they've actually introduced a few years ago. That's actually quite working for a lot of companies, and like in Europe now, they're all moving towards SUI and OGC standards for like even big phone carriers like Vodafone, Orange, But I think that would be quite good even for creating other things. I mean, that would be the way towards a free and kind of open source platform framework.
Yeah.
And regardless of Zigbee or 15.4 and all that goes underneath. I mean, if the standards on top is like XML schema and OGC, that would make it like pretty good.
Yeah, I agree. Okay. Any other questions? I don't know how I'm doing on time. Okay, well, somebody gonna let me know when I'm running out of time? No?
5 o'clock.
Oh, 5, thank you. Okay, so let me go back. So I'm gonna switch to and talk about demand response demo. And just a couple of different concepts to cover for those who might not be familiar with that. So demand response is a concept that was in existence for, at least here in North California, in the US, for over 20 years. Its basic notion is that utilities have a way of influencing consumers' behavior by by using variable, by using a variable price for electricity. In other words, when electricity supply or electricity demand outpaces supply, they have a way of raising prices of electricity real time, communicating it to consumers so that will force a reduction of energy usage. That's a basic concept. The way it existed pretty much so far was the utility guy picks up the phone and calls Oracle and says, Oracle, you're part of our demand response program, and price for electricity, we're just raising price for electricity, or demand outpaces the supply. We want you to, according to our agreement, to reduce your electricity by 20%. Right? And some building manager or whoever just goes and, well, not manually turns off lights, but use whatever building automation systems that implement in a company to reduce electricity usage. So it was very manual. So automated demand response is essentially automate that process. And there is a notion of demand response automation server, or DRS. It has generally it has two different sets of API. There's APIs that are exposed for utilities to integrate in their own processes and services so that it communicate with a demand response server, so-called shed events. Shed events in the utilities indicates, in the utility world indicates that they require consumers to shed the electricity use. It's called shed event. So the APIs that can be used to communicate with demand response server indicate that event happens. And downstream API or client APIs that are used by those who develop appliances or devices that are capable of responding to demand response server to consume, to receive that signal and accordingly adjust its functionality to reduce electricity. So that's basic concept of demand response. And Zigbee we've already talked about. Again, for those who might not be aware, Zigbee is one of the M2M communication protocols, low power, low bandwidth, mesh networking-based communication protocol that is built as highly reliable protocol used in various M2M applications. As I mentioned, every PG&E meter has a Zigbee chip in it that is meant to be a center of the home area network, home energy management network within homes, eventually, someday. So we already covered that, I guess, but so Zigbee Alliance defines right now, with the caveat that they start moving in the latest specification to IP-based communication. But they rely on a standard RF-based transport layer. It's IEEE 802.15.4. And they defined a bunch of specification on API security networking layer. They basically define how the Zigbee network going to look like, what the security standards are. And they define a number of different so-called profiles are used in various different type of applications. Home automation, smart energy, remote control, healthcare. There's probably nowadays almost like a dozen of them. And you can, I guess, read it. It's very low bandwidth, 20 to about 200 kilobytes per second. Range is 30 to 20 meters. There's two versions. There's XB and XB Pro, and slightly vary in its range and the bandwidth. And its reliability comes from the fact that Zigbee network can support upward of 6,000 nodes. I think it's like 6,500 nodes that maximum it can support, which means that the more nodes on network, because it's a mesh networking protocols, meaning data can go from any node to another node, from one node to another node through a number of different routes. So the more nodes on the network, the more reliable it is, and its reach could be quite big because of the potential size. So demos, again, there's something that you guys can see at the demo floor today, or probably not today, tomorrow. It's closed today. We built the demo on the Kyle Cortex M3 board. For those who do hardware, it is a ST micro board with running at, I think it's 122 megahertz processor with 124 kilobytes onboard memory, 2 megabytes flash. so we use as a XB Zigbee coordinator. Coordinator is a center or initiator of Zigbee network, which communicates with a board over serial port right here. And we're using, at the demo, we're using a couple of Zigbee modules connected to lamp and a fan. So what you will see on the demo floor. And it communicates with a demand response server. And we're using a real demand response server by, yes?
I didn't mean to interrupt, but I was just curious about what kind of security that Zigbee has. So let's say my home is running a number of devices that are all running on Zigbee, and there's a coordinator module. If somebody rolls up outside my home with a laptop and a coordinator module, what can they do to my house if they're suddenly make themselves part of my mesh network?
Okay. Well, it does, as you saw in the previous slide, it does have a standard security mechanism. I'm not a Zigbee expert, so I probably know about Zigbee maybe a little bit more than some of you, but certainly not enough to give you inside details. I don't know, Steve, do you know what's this, specifics about Zigbee standard security?
Well, when you set up your little demo, how did you get your power outlet and your Zigbee coordinator? How did you get them talking?
Oh, did you want to? Okay. So the process of the way the coordinator and the module are sync up with each other is done. So the way you configure your Zigbee coordinator to accept a specific type of devices. So there's a way, usually it is done by manufacturer or by service provider or whoever deploys Zigbee solutions. They configure the Zigbee coordinator to expect specific type of devices and use a specific type of security. Just like, when you configure your Wi-Fi network, you decide what security protocol you're going to use, right? When you are syncing up devices, you have to enable the sync function. And Zigbee devices, in this case, those network plugs, network-enabled Zigbee plugs, have a, you press a couple of buttons simultaneously, and it's looking for the network that matches. It's with a specific credential, so it syncs up with the local network if it matches credentials and other parameters.
So it sounds like it's kind of similar to the way Bluetooth pairs.
It's kind of the same, except that you don't, since there is no interaction, there is no UI per se. You have to it has to be pre-configured in the firmware of the devices.
Okay.
Yes.
Is it a problem that, for instance, Zigbee is like envision the network as a heterogeneous network, and it's not homogeneous? Because you've got full function devices, reduced function devices, coordinators, routers, and it's not like interacting with this kind of network. It has to go through certain gateway, and it doesn't make make some room for like the new devices to join the network easily, seamlessly, and that would make it very difficult. Deploying Zigbee in higher scale.
Yeah, I understand what you're saying. We are not, I'm not a big proponent of Zigbee per se. Right? I'm aware of its limitations, at least to the extent that I understand Zigbee. I also don't particularly like the way that it's closed specification, right? And only give access to the members, and you have to pay like a boatload of money to get into that. So as a developer, you can't really work with it. You have to either shell out tons of money to get to start development, or work for a company who does it for you, right? So I don't particularly like that either. We just pick that for our demo, right? We pick that just because for whatever reason it sees a adoption in the smart energy space. PG&E is not the only example. There's other providers who are using Zigbee for the smart energy networks. Yes.
I was talking to one of the guys from the Zigbee Alliance, and he basically told me they did Just want companies, they have approached LG, Samsung, all the big vendors to, to integrate Zigbee, but they don't want developers to basically get their hands on it first.
Yes,
I think that's a problem because if developers get into it, then the company's going to approach it.
Yeah. Well, it's certainly, we're here at Java 1 conference and developer conference. I certainly understand what you're saying. Well, I guess Zigbee, they're going after big bucks. That's what they do, right? They figure that the quickest way for them to promised land is to work with large companies. I'm sort of a business guy. My one foot is in the business and the others in the technology. So from business perspective, and it's something you guys might not like it, but from business perspective, it could make sense, right? Because again, if we're going back to somebody who can push specific platform, right? It could influence adoption of a specific platform. It usually happens it happens when large corporations put money in it. That's reality, right? If you look today, who has application servers, right? The most used application servers. Even Red Hat, JBoss, it's probably one of the most open ones. There's a still business model behind it, right? Oracle, IBM, all, Microsoft. We'll come to that. So it's,
Do you believe that Zigbee is can be replaced by IP devices, or we really need the mesh network? Because SparkFun, they are selling the electric imp, which is an ARM Cortex M3 with Wi-Fi inside and $30.
yeah, I like that. I'm on the list, but they didn't send me anything yet.
Yeah.
Even though they're local, I don't know, they ignore local guys. Do I believe that Zigbee could be replaced? Yes, right? It could be. I think that mesh networking has benefits. We talked about it. I heard that Z-Wave, which is also proprietary, seems to have a lot, from the mouths of our partners who are using different communication protocols. I have heard multiple times that from a reliability point of view, they like Z-Wave a lot more than Zigbee. But Z-Wave is controlled by one company, right? I think it's Sigma, or Z-Wave chips are done by one company. So it's even more proprietary than Z-Wave. I mean Zigbee. It probably will take with a developer, some very smart guys, to come up with a communication protocols that are going to be appealing enough to get adopted in the bigger companies. Yes.
I guess the main differentiation between the different RF modules is the low power, long battery life.
Absolutely. Absolutely.
You can have a low power Wi-Fi, but you don't have the mesh networking. With the Zigbee, you get the mesh networking, the resilient networking.
Oh, absolutely. That's why I made.
And you get the long battery life.
Mm-hmm.
And so in mission critical situations where you cannot simply replace the battery in 5 years, 10 years, like it gets needed, you have no choice to pick Wi-Fi. You have to go with this low power, low data rate.
Quite.
And likewise, in medical situations, you cannot replace your pacemaker every day. Right?
Yeah, absolutely. Absolutely, yeah.
You cannot charge every day.
Well, who knows, You're going to have a power outlet that charges your electrical vehicle. You might as well.
Right, so these are the trade-offs among all this technology.
Yeah, right.
So for gas meter, definitely.
Yeah, absolutely. So low power reliability is a crucial component. Yes.
For gas
Yeah.
meter, it's every 5 years to 10 years before you replace that.
Yeah, absolutely.
I kind of feel like we're at, in this space, we're kind of at with all these protocols, they're still proprietary, and I kind of feel that they're a lot like Token Ring. Token Ring was controlled by one company, and for its day,
I agree, but think about that. The M2M applications involved millions and millions of deployed devices, right? Smart meters, I mentioned, 9 million devices. Can you imagine the cost for PG&E to replace that, right? So it's, if in the enterprise space, it's probably easy to, relatively easy to go and open a open bay on your server, insert another, Ethernet module, right? Or if somebody will come up with something next generations that works on the same bus in a computer, just insert it, right? And you have 1,000 servers in your data center, it'll do it 1,000 times. So it's not going to be easy for PG&E to replace 9 million Zigbee modules in the field, right? So the point is that whether you like or not Zigbee, or whether you like or not other proprietary communication technology, if they're getting adopted and deployed, we might be forced to work with them.
Six low pan be an option? Provide you high addressability, low power, open standard. It seems like a viable.
Absolutely. In fact, if you're familiar with the Sunspot, right, that's what it uses. And our Sunspot guys are very keen of pushing that, and I agree with them, and they really don't like Zigbee. Right?
Yes. Zigbee 2.0 will support 6 low pan.
Yes. Yes.
And it will have all the security.
Yes. I hope you're not with the Zigbee Alliance. I don't mean to offend.
We are the free scale semiconductor.
Okay. No disrespect to Zigbee. I mean.
We are the usual suspect.
Okay. Right. So yeah, the Smart Energy 2.0 is moving away from specifying transport layer, and 6LoWPAN is one of the options they're going to support. Yeah.
I think what you were saying, and that might be a good point, that if they want to keep it proprietary, obviously for business reasons, but as you're saying, if it's open, then a lot of people can hack it, and do you want people to be able to hack stuff that's in your house? I mean, right now, if somebody hacks into your business, your company that you work for is app server.
We're done?
Okay, then you go home,
Okay.
it's not happening into your house.
Yeah.
Right?
No, security is critical, and I'm getting cease or desist message.
We have sessions starting immediately, so.
Oh, I'm sorry.
Still need to go out and refresh them.
Okay. Thank you, guys. I really appreciate your participation. It was very cool.